section 2.4 and 2.5 are going to be about linear functions and equations of lines and linear models. So I want to talk to you a little bit about vertical and horizontal lines to start with. A horizontal line has a slope of 0 and equations that are in the form y equals a number. Those graphs for a horizontal line, if this is our coordinate plane, a horizontal line is going to be horizontal, and the domain for a horizontal line will be all real numbers, negative infinity to infinity, because we scan left to right, it goes all of the x values, but the range for a horizontal function is just going to be whatever that number is. So it is a single value that is just whatever the value of that number is. A horizontal line is a function, and in fact it's a constant function because it's not, the slope is 0. Slope is 0. As opposed to a vertical line, vertical lines have an undefined slope, and their equations are in the form x equals a number. On the coordinate plane, a vertical line will be straight up and down. It is vertical. Vertical lines are not functions because they fail the vertical line test. The domain for a vertical line is going to be whatever number that vertical line goes through, and the range will be all real numbers because when we scan the graph bottom to top, it covers all of the y values. One form for equations of a line is called standard form. Mostly we'll talk about standard form and slope-intercept form. We'll also talk about point-slope form. But standard form is in this format, ax plus by equals c. Some textbooks use different versions of standard form, but in this textbook, a, b, and c must be integers, which means they can't be fractions or decimals. Also, a needs to be positive. So this leading coefficient on the x needs to be greater than or equal to 0. However, if a is equal to 0, then b has to be greater than or equal to 0. The greatest common factor of a, b, and c must be 1. That really just means, like, I can't have 6x plus 4y equals 8 because those all have a greatest common factor. I would have to divide everything by 2 and make that 3x plus 2y equals 4. Alright, so let's, in order to graph a line in standard form, graphing a line in standard form, we are going to use what I call the cover-up method. I don't think that is actually a thing that anything is called. It's just what I call it because it's what it reminds me of. So to graph using the cover-up method, what we're going to do is literally cover up this minus 5y. So when I cover up minus 5y, I have 3x equals 24. Then when I cover up 3x, I have negative 5y equals 24. One thing you have to keep in mind is that you've got to keep the sign with the coefficient. So positive 3x and negative 5y. Then we're just going to solve those two tiny equations. Divide both sides by 3 there, so we get x equals 8. And that's going to give us an x-intercept at 8, 0. Then I'm going to solve this other equation, divide both sides by negative 5, so I get y equals negative 24 fifths. That is going to give me the y-intercept at 0, negative 24 fifths. Then when I graph that, that line. See, negative 24/5 is like almost negative 5. So if I go like 2, 4, 6, 8 on the x-axis, put my x-intercept, I go negative 2, negative 4, negative 6. Negative 24/5 is like close to negative 5. Once I have those two plotted on there, I will just connect them. I don't have a straight edge. I'll just use this little debit card here. Remember that you want to go all the way to the edges of your graphs and put arrows on the ends of your lines. So this other one is kind of a bit of a special case. If I start to do that cover-up method, so I cover up 7y, I get 2x equals 0. I cover up 2x, I get 7y equals 0. Divide by 2, I get x equals 0. Divide by 7, I get y equals 0. So here I have the x-intercept and the y-intercept are both at 0, 0. So when I go to graph this, I'm only going to have one ordered pair, and that's not going to get me a good graph. So I have that one ordered pair at 0, 0. But then I'm going to need to actually just choose another ordered pair. Like I will just pick a value for x or a value for y and figure out a second ordered pair to be able to graph that. So that's going to be the dog. Oh, maybe she's not going to bark. So we will just pick like x equals 3, for example. Doesn't really matter. So I do 2 times 3 plus 7y equals 0. So that is 6 plus 7y equals 0. Subtract 6. 7y equals negative 6. Divide both sides by 7. And I get y equals negative 6 sevenths. So that's going to give me another ordered pair at 3, negative 6 sevenths. So I go out to 3. Negative 6 sevenths is not quite negative 1. So I'll put that ordered pair kind of out in space there. And then connect those 2 points. And that's going to make that line. Let's talk about slope. Slope is pretty important. It measures how steep the line is. It also measures which direction the line slants. Geometrically, we can interpret that as the ratio, meaning fraction, of rise to run. We use slope to describe how slanted a highway is or a roof. In that case, it's called a grade, and it's often given as a percent. So like 10% would be a slope of 10 over 100, or 1 over 10, which means we have a rise of 1 for every 10 units of run. When we figure out the slope, the traditional formula is to do y2 minus y1 over x2 minus x1. And so that's probably what you have seen for slope. So let's bubble this out. M is the letter we use for slope. I say the words rise over run. This little triangle symbol means delta, and well, it is delta, and what it means is the change in y. So it's the change in y over the change in x. So we're going to subtract our y's in the numerator, subtract our x's in the denominator. And it really does not matter which is 0.1 and which is 0.2. I can subtract my points in either order as long as I am consistent. So I just remember slope being rise over run, and then rise rhymes with y's, and sometimes people want to run from their x's. So rise over run, subtract your y's in the numerator, subtract your x's in the denominator. Really very much try not to get upside down when you are doing these problems. So let's find the slope of some of the lines through some of these points. So I'm going to do this one. I'll do it like in both orders so you can see that we do get the same thing. So if I use this as my first one, so I'm going to do like 2 minus -4 and -3 minus 8. So I need the y's in the numerator. So this is a y, this is a y. So -3 subtract 8. Notice I started with this point and went subtract this one, so I have to do the same thing in the denominator. I will do 2 subtract -4, which is going to be -3 minus 8 is -11. 2 minus -4 is 6. So that is a slope of -11/6. Now, if I went the other direction, no, I didn't label these as x's. I gotcha. If I go the other direction, so instead of taking -3 subtract 8, I'm going to go the other way. 8 subtract -3. 8 subtract -3. Then I have to go the other direction in the denominator as well. -4 subtract 2. So that is going to give me 11 in the numerator and -6 in the denominator. That just looks awkward. When you have a negative fraction, you want to put your negative either out in front of the fraction or attached to the numerator the way it is there, but those are equivalent. So it really doesn't matter which direction you do your subtracting as long as you go the same way in the numerator as you do in the denominator. So let's look at B. To find the slope, I want to subtract my y's in the numerator. So I'm going to do -4 subtract 7. -4 subtract 7. In the denominator, I need to subtract my x's. So since I did -4 subtract 7, I need to do 2 subtract 2. That is -11 divided by 0. Since you cannot divide by 0, this slope is undefined. And we know what kind of line that makes. We talked about it in the previous page. A slope that is undefined is going to be a vertical line. So we know that this would make a vertical line. Let's look at our last one, letter C. 5 -3, -2 -3. So slope. Remember, we're going to subtract the y's in the numerator. So if I do -3 subtract -3, then subtract the x's in the denominator, 5 minus -2, I get, well, that's -3 plus 3, which is 0, over 5 plus 2, which is 7. So this slope is 0. And we saw on the previous page that a slope of 0 is going to be a horizontal line. So this would make a horizontal line. Finding slope from an equation. Oh, let's talk about slope down here. What do those slopes look like? So this first slope that we got is a negative slope. Negative slopes slant downwards as we go left to right. So they fall from left to right. Positive slopes go uphill as we go left to right. So they rise from left to right. And then a slope of 0 makes a horizontal line. So it is a constant slope. And then an undefined slope is a vertical line, and it doesn't, I don't know, it's just undefined. I can't explain it a better way. So let's find the slope of this line. This line is given to us in standard form. One way for us to find the slope would be to rearrange it into slope-intercept form, which we're going to talk about on like a couple pages from now. So I'm not really very certain why they put that right here in the notes, but that is what it is. We'll figure it out. So in standard form, we have ax plus by equals c. We are going to rewrite that into slope-intercept form. slope-intercept form is y equals mx plus b. So remember that m is the slope, so we're going to be looking for the coefficient of x, when we have it as y equals. So our first job, when we have 4x plus 3y equals 12, is going to be subtracting the 4x to the other side of the equation so that 3y is by itself. So now we have 3y equals 12 minus 4x. Then to get it to be y by itself, I will need to divide each term by 3, like that. So I have y equals 4 minus 4 over 3x. Now this is not in slope-intercept form at the moment, because in slope-intercept form, the x term is first and the constant term is second. But I can still identify the slope by looking at the coefficient of x, which is this number right here, negative 4/3. So the slope of this line is negative 4/3. It does not have the x in it. It is just the number, the coefficient like that, which means that if I were to graph that, it would fall from left to right, meaning that it slants downward. Let's go ahead and plot a line that goes through the point negative 1, 5 and has a slope of negative 5/3. So when it tells us a point that the line goes through, we are going to plot that point. So I'm going to put negative 1, 5 on my graph. So negative 1 on x, 5 on y. And then the slope is negative 5/3. So slope being negative 5/3 tells me that the line is going to slant downwards. And the numerator is the rise. So I'm going to be rising 5 and running 3. So if I start from the point that we were given, negative 1, 5, and I rise 5, well, that's going to put me up in here. 1, 2, 3, 4. If I rise 5, in order for my line to slant negatively, I'm going to need to run 3 to the left before I put my point right here. But if I start from the point they gave me and I move down 5, 1, 2, 3, 4, 5, then in order to get my line to slant negatively in that direction, I'm going to need to run 3 to the right and put my point right there. Then when I connect my dots, I'm going to use I would use a straight edge, but like I said, I'm not really very prepared right here. We're going to connect those. I want to go all the way off the edge of my graph paper that I'm provided and put arrows on the ends of my lines. The domain for a line that looks like this, as I go left to right, the domain would go negative infinity to infinity, because the first thing I hit is an arrow, second thing I hit is an arrow. And the range, as I go bottom to top, also goes arrow to arrow, so the range is also negative infinity to infinity. Average rate of change is really just fancy words for slope. Remember, in function notation, f of x means y. So f of b means the y value when x is b. So this is the y value when x equals b, and this means the y value when x equals a. So I'm finding the slope between 2 points, a f of a and b f of b. So do not let average rate of change mess with you. It really just means the slope of the line between 2 points. So, here we go. In 2013, Amazon spent $6,566 that number million on research and development. In 2017, they spent $22,620 million on research and development. We're supposed to assume a linear relationship, meaning that they connect in a straight line, and find the average rate of change, which just means slope, average rate of change, slope, in the amount of money spent on research and development each year. Graph as a line segment and interpret the result. So we've already got the graph, so we don't have to make the graph. We just have to find the average rate of change, which means the slope between the 2 points. So the average rate of change will be, using our slope formula, take y2 minus y1, so 22,620, subtract y1, 65, over x2 subtract x1. So 2017 subtract 2013. So when we do our subtraction, we are going to get 16,055 divided by 4. Now, I'm going to go ahead and divide those numbers, but before I do that, I want to think about the units that we are measuring these in. The 16,055 is in dollars. The 4 is in years. So when I simplify this fraction, 16,055 divided by 4, I get, if I'm rounding, about 4,014. But it's over 1. So now my units are, well, it's actually $1 million, right? So now my units are $1 million and 1 year. And this little fraction bar means per. It means for every. So to interpret this, I would say that they spent an average, because we found the average rate of change, an average of $4,014 million per year on research and development. Now, even if my model doesn't make a straight line, I can still find the average rate of change the exact same way. So here, the blue is the model, and I just want to find the average rate of change between these 2 years from 1970, so this would be the year 2000, to 47, which would be 2017. So if we want to find the average rate of change from 2000, that's this year, to 2017, that's this year, we connect them with a straight line, like they showed us, and the average rate of change just means find the slope between those 2 points. So we're going to take y minus y, so 3612 minus 1329.4 over x minus x, so 47 minus 30, which is something over 17. Let me work that out. 2282.6 over 17. My units are billions of dollars, billion, per years. So when I divide that and round it, we're just going to round to the nearest tenth. So that is going to be about 134.3. So I would interpret that and say that they spent an average of $134.3 billion per year.